Here's your warm-up for lesson 18, an introduction to functions. Some absolute value equations. We've got our positive side, 3x minus 2 equals 7. Our negative side, 3x minus 2 equals negative 7. We can add 2 to both sides. 3x equals 9, divide by 3, x equals 3. Our negative side, our steps will be the same. Negative 7 and 2 makes negative 5. Divide by 3, and x equals negative 5/3. For our absolute value inequality, we do the same thing. Positive side, 2r plus 1 is greater than 5. And our negative side, 2r plus 1 is less than negative 5. We'll subtract 1. 5 minus 1 is 4. Divide by 2. Divide by 2. And we get r is greater than 2. Our steps will be the same. Negative 5 minus 1 makes negative 6, and divide by 2. And we get r is less than negative 3. So our numbers are negative 3. We don't have the equal sign, so an open circle. And less than negative 3 would go to the left. And our other number is 2. And we're greater than 2, so that would go to the right. So this is an OR equation. Homework questions we'll skip. Today we're going over introduction to functions. So our title, we're going to learn what is a function, how do we identify a function. We're going to learn about words like domain and range as well. So a function is a rule that establishes a relationship between two quantities called the input and the output. For each input, there's exactly one output. More than one input can have the same output. One way to describe a function is to make an input-output table. This table lists the inputs and outputs shown in the diagram. So this is an input-output table, and this is our diagram, and this shows us what our inputs and outputs are. The collection of all input values is called the domain of the function, and the collection of all output values is the range of the function. The table shows that the domain of the function above is 0, 1, 3, and 4, and the range is 1, 2, and 3. So some words that will go along with those that you're going to want to know. You're going to want to know domain and range, input-output table, what an input is and what an output is. Inputs are usually associated with the letter X in algebra, and outputs are associated with the letter Y in algebra. Inputs are also associated with the domain values, so the X's are domain values as well. Our inputs, our X values, our domain, they're all kind of replaceable with each other. Our output, our Y values, and our range are all replaceable with each other as well. And when we get into graphing, I'll show you what we mean by X and Y. We can do it here. On a coordinate plane, we've got our x-axis, that's the horizontal line, and we've got our y-axis, that's the vertical line. And we plot these points by having a two-digit number that's x and y, separated with commas. That's not really a number, it signifies a spot in space. So what do I mean by that? So I could say I'm at the point 3, 2. So that means that I'm at the point, if I were to say I'm at the point 3, 2, that means my x value is 3 units to the right. We start at 0, 0 is where everything starts at, right in the middle. So 3, 2 would be 3 units to the right on the x-axis. 1, 2, 3, and 2 would be 2 units up on the y-axis. So that would be the point 3, 2. My input would be a 3, and my output would be a 2. The 3, 2. My x value is a 3, my y value is a 2. My domain would be a 3, and my range would be a 2. We could do another point. Let's say we had the point negative 4, 3. So negative 4 would be moving negatively on the x-axis, so negative 1, 2, 3, 4. And 3 would be 1, 2, 3 on our y-axis, and that would be the point negative 4, 3. Negative 4 to the left and up 3. My input is negative 4, my output is 3. My domain is negative 4, my range is 3. My x value is negative 4, my y value is 3. So what we have is just two number lines, a number line that's a horizontal number line and a number line that's a vertical number line, and we mix them together to get a point in space. Let's do one more. Let's say our point was negative 3, negative 2. So that would be moving to the left 3 on the x-axis, 1, 2, 3, and then down 2 on the y-axis. So that would be the point negative 3, negative 2. Left 3 and down 2. And we can do another. Let's say the point 5, negative 1. So that would be moving 5 to the right, 1, 2, 3, 4, 5, and down 1 on the y-axis. 5, negative 1. My input would be 5, my output would be negative 1. My domain would be 5, my range would be negative 1. My x value is 5, my y value is negative 1. So we can say, is a line or is an equation a function? And we consider something a function. If we go back, a function is for each input there's exactly one output, meaning for every x value there's only one y value. For each input x there's only one y output, because inputs and outputs are x's and y's, just like domain and range are x's and y's. Now how I remember that is I comes before O in the alphabet, X comes before Y in the alphabet, and D comes before R in the alphabet. So we say, we can look here and we can just pick out a point, and this point right here is the point 4, 2. So that means when we input a 4, we get out a 2. And the reason why this particular line or shape isn't a function is because I also have another x value here that's a 4, but now my output is negative 2. So for the same input, I have two different outputs, and that makes this not a function. Now how we do that then is we just say, well, anytime I can draw a vertical line through a graph and go through 2 points, that makes it not a function. And you can see when we have a straight line that we could draw all kinds of vertical lines, and we're only going to go through the line at one point. For every x value that we input, let's say we inputted a negative 2 for an x value, so negative 2 and we find where it crosses our line, when x is -2, xy, then our y value is is positive 1. That's the point 2, -2, positive 1 right here. Okay, -2, positive 1. Every time I find this line and I go to -2, it's always right there. It's always at -2, 1. Where here, if I was at 2, I'm right here, but 2 is also right here. That's why this one doesn't pass the vertical line test. This is not a function, and this one is a function over on this side. Yes, it is a function. It passes the vertical line test. Now, inputs and outputs, we can also look at it as charts. And so what we could say is, for an input of 0, I get an output of 0. That's the point 0, 0. That's also called the origin. For an input of 1, I've got the point 1, 1. So I've got an output of 1. But I also have, for an input of 1, I also have the point 1, -1. And anytime I have the same input, but I get different outputs, I consider this not a function. We could continue this. Go to 4, I could skip a couple. 4, 2, and 4, -2, and you can see how there's 2 outputs for the same input, a 2 and a -2. Now, for a domain, listing our domain is all of our input values. So let's just say that we just did these. So my domain would be 0, 1, and 4, because that's the only points that I plotted. Now, if it's this line, it includes every point along this line, but we don't have, it goes out for infinity. And we'll talk about that here on the next one. But for just this table here, my range would be all my output values, which would be 0, 1, -1, 2, and -2. 0, 1, -1, 2, and -2. And we could put those in order if we wanted to. So let's talk about our domain and range here, and we'll pick some inputs. We could have the input of -6 out here, and my output, this is the point -6, -7, so my output would be -7. And I don't have another point where x is -6. So this, we can see also with our vertical line test that this has to be a function, because we're only crossing at one point. We could pick some more points. How about -4? -4 for an input would give us an output of -3. That's the point -4, -3. We could pick a point -2. Our output would be 1 here, -2, 1, -2, 1. We could pick some positive points. They don't show up on our graph, but that would be the input of 1 and the output of 7. 1, 7. So right here, our domain, for just this table, our domain would be -6, -4, -2, and 1. And our outputs, or our range, would be -7, -3, 1, and 7. -7, -3, 1, and 7. Now, in a function where we're creating a line, I'll just tell you that this function is y equals, we're going up to, so y equals 2x plus 5. So that's the line, y equals 2x plus 5, and we'll explain how to do this as we move along in the lesson, or in the unit. So in this function, this line's gonna go on and on forever to the right, and as I move to the right, and moving to the right moves along your x-axis. So as my x values increase, what can we see is happening to our y values? Our y values are increasing. And as our x values decrease, as we move to the left on this line, what happens to our y values? Our y values decrease as well. And this line's going to go on and on through infinity. So we could say that our domain, when we're talking about the line, the actual line, not just this table, our domain is going to be all real numbers, and we said our shortcut for that is all real numbers. That's this symbol here. Our range, that means that it can go on and on forever to negative infinity and a positive infinity. Our range, well, as we move to the left, we keep on getting lower and lower and lower, so that's going to negative infinity. And this, as we move to the right, we're going higher and higher and higher, so that's going to positive infinity. So our domain and range is both all real numbers. And you'll get that for all linear equations, your domain and range is all real numbers. How I also think about functions, whether or not something is a function or not, is I think about like a Coke machine like you see in the hallways, or a Pepsi machine, or whatever we have now. And what I mean by that is, when you go to the Coke machine and you press the Coke button, you put in your money, you press a button for a Coke. If you get out something other than a Coke, when you press that Coke button, the machine isn't functioning properly. So that's not a function. If you press the Coke button and sometimes you get out a Coke, and you press that same button, and then you get out a Mountain Dew, well, I'm getting, for that same button press, I'm getting out two different things. That doesn't make sense. That's not functioning properly, so that wouldn't be a function. Now, if I press the Coke button and I get out a Coke, and every time I press that Coke button I get out a Coca-Cola, then the machine is functioning properly. That is a function. That means every time I press the button I get out the same thing over and over again. So we could describe that using numbers. You know, when I press just think about when I input a 1, let's say I get out a 2. When I input a 2, let's say I get out a 3. When I input a 3, I get out a 4. When I input a 4, I get out a 5. When I input out a 5, I get out a 6. When I input a 6, I get out a 7. Now let's say that we inputted a 1 again. For this chart to be functioning properly, when I input a 1, what do I have to get out? I have to get out a 2. If it's not functioning properly, I get out something other than a 2. Now, we can press, imagine yourself pressing this input more than once. When I input a 1, I get out a 2. When I input a 1 again, I get out a 2. When I input a 2, I got out a 3. When I press it again, I get out another 3. When I input a 3, I got out a 4. When I input a 3 again, I get out a 4. For this not to be functioning properly, when I inputted one of these again, let's say the 3, we hit it the second time, and now we get out a 5, that's not functioning. For the same input, I'm getting out two different outputs. My input is a 3 sometime, or my output is a 4 sometimes, and sometimes my output is a 5. That doesn't make sense. That would make this not a function. Now, also, we can have the same output for different inputs. What do I mean by that? I can input a 1 and get out a 2. And don't pay any attention to what we did here. This chart doesn't affect this middle chart. So now every time I input a 1, I gotta get out a 2 for this to be functioning correctly. But what can also happen is I can input a 2 and also get out a 2. as long as every time I input this 2, I get out that same 2. I can input a 3 and get out a 2, that's fine, and I can input a 3 and get out a 2. And this is still functioning properly, even though they have the same output. It's still a function because every time I do it, I get out the same number that we started with. So my analogy to that would be if you have the multiple Coke buttons or Diet Coke or whatever you have, but you press the top Coke button, you're still going to get out a Coke, and then I press the other Coke button, I'm still going to get out a Coke, as long as every time I press those buttons I get out what I want. Now, function notation, this is function notation. Whenever we're saying, this would be, I'd read this h of x, and most of the time function notation is written like the one on the right where it says f of x. But they're all called function notation, and that means the value of my function at x. And so these are just x's, and so it's just a way of showing the relationship between x's and y's, or domains and ranges, or inputs and outputs. So what do I mean by that? I mean, my value of this would be the saying, what's the value of your function when x is 4? That's what that's saying. And so what we'd do is we'd substitute in a 4 for this x. So we'd say when this x right here is 4, right here, and I could rewrite this function, I'd say 4 plus 7. And the value of my function when x is 4 is 11. So that makes the input-output of the point 4, 11. X and y, or inputs and outputs, or domains and ranges. To do what's the value of my function when x is 0, I substitute in a 0 for x. So I say 0 plus 7. What's 0 plus 7 is 7. My point there would be the point 0, 7. When I input a 0, my function gives me a 7. Negative 2 for x, negative 2 plus 7, that makes 5. My input-output would be negative 2, and my output would be 5. We can do it with another function. Now, I missed the parentheses here. So this just means to substitute in a 4 for x. So we'd say 2 times 4 minus 5. And now we've got a little order of operations problem to do. 2 times 4 makes 8, and 8 minus 5 makes 3. So when I input a 4, my output is a 3. Every time I inputted a 4, I'd get out a 3. Every time I do it. What's the value of my function when x is 0? We'd say 2 times 0 minus 5. What's 2 times 0 is 0 minus 5 is negative 5. My input-output would be the point 0, negative 5. When I input a 0, I get out a negative 5. The last one, 2 times negative 2 minus 5. 2 times negative 2 is negative 4. Negative 4, minus 5 is negative 9. So when I input a negative 2, my output is a negative 9. And we could make an XY t-table or a chart with these values. Here's an X, Y t-table, and that's just listing these numbers. When x is 4, y is 3. When x is 0, y is negative 5. When x is negative 2, y is negative 9. And you'd be asked, okay, list your domain. Your domain would be 4, 0, and negative 2. Your range would be 3, negative 5, and negative 9. Our homework is homework 18.